Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 2 still on vectors in 2D. And then it says a bald eagle with a mass of 5 kg is perched on a light, inextensible rope between two poles as shown in the diagram. The eagle is stationary on the rope. Then 2.1 says, what is the magnitude of the resultant force of the system? Now, if they say the eagle is stationary, we do understand that the whole system now is at equilibrium. So all the forces are balanced. And then we know that equilibrium is when the resultant force is equal to 0. So what we are supposed to say here is just 0, or you can indicate as 0 Newton. So always note that if we say an object is stationary or the system is at equilibrium, then that simply means that our resultant force of the system is equal to 0 newtons. Then 2.2 says, draw a label-free body diagram showing all the forces acting on the eagle. Note, a free body diagram, not a vector diagram. So a free body diagram, this is how we do it. We indicate the dot here, which will be indicating the object. Then we know that this eagle here is experiencing the force of gravity because everything on planet Earth has the force of gravity, right? Then we have F1 there going all the way up. And then there we have F2 going diagonally like that, right? So that's all you indicate for 3 marks. You just show all the forces acting on that eagle. So it experiences the force of 1, the force of 2, and the gravitational force. Right, then 2.3 says calculate the weight. So to calculate the weight, we need to say W is equals to M times G, mainly because we can see that we are given the mass here. So remember, they told us the mass of 5 kg. Then mass is 5, and then our gravitational acceleration is 9.8, right? Then having to multiply the two, we have 49 newtons. So for 3 marks, that's all you needed to do there. So just simply write the formula and then substitute into the formula and the correct answer. Now, if you wanted to indicate the direction, there's no problem with that. You could have said downward because you know gravitational force is always acting downward. Right, then let's move to 2.4. So for 2.4, it says calculate the magnitude of F1 and F2. Now, in order to calculate that, we would obviously need the aid of our vector diagram here. So the first thing that we would have to do, let's just draw the diagram of forces, or the triangle of forces, which will be a closed vector diagram since we said that the system is at equilibrium. So we have our weight or gravitational force going down like that. Then look at this. I mainly take the forces as they are. So remember, it's a cut and paste method. You do not have to change anything. So that's F1 going all the way up like that. And then that's F2 also going all the way up like that diagonally. So and then let's just close off here. So now to label, I have the FG, or some others might prefer to write it as W, which we already calculated. It's 49 newtons. Then here we have F1, and then up here we have F2. Now you have to test that the angles that you are given here will really be between the normal and the force. So if you are using alternate angles here, you can see that the 30-degree will appear there. So which makes it a good angle to put in there, because remember, the angles that you put inside your triangle must be the angles that are between the normal and the force, right? So that's 30 degrees. Then also here, if we do alternate angles, that's a Z forming or a Z. that's 60 degrees. So we should also put 60 degrees here. Now the 60 and 30 forms 90. So in order to complete this triangle, we need 90 degrees here, so that all the interior angles add up to 180 degrees. Now that we have a perfect right angle triangle, we know that this is a closed vector diagram. Now to calculate the values for F1 and F2, we would obviously have to use SOH-CAH-TOA since we have a right angle triangle. Note that these are only applicable for right angle triangles, right? So this is only for right angle triangle. Then if it's not a right angle triangle, we know we have already discussed in the previous question that you use the sine rule, right? Okay, so now to calculate F1, we can choose to reference from the 30 degree here. So if we reference from this one here, that means the F1 becomes the adjacent side, and the one that we have here, the weight, is the hypotenuse side. So that means we would end up having what? Let's quickly calculate that. So we have cos 30 degrees is equals to adjacent over hypotenuse, which is 49. Then for F1, we will have 49 cos 30 degrees, which if you punch into your calculator, this gives you a value of 42.44 newtons, rounded off to 2 decimal places, right? Then that's how you find your value for F1. Now we want to find the value for F2. So to find the value for F2, if again we reference from the 30 degrees, that means F2 is now what? The opposite side, but then we are still given the hypotenuse side. So we can say this is sine 30 degrees, meant to say. So let me write it proper. So we have the sine 30 degrees is equals to, the opposite is F2, and the hypotenuse is the 49. So to calculate F2, we need to say 49 sine 30 degrees, and then our F2 now is equals to what? It's equals to 24.5. So it's 24.50 newtons, rounded off to 2 decimal places, of course. Right. So, and then that's how you could have calculated the magnitude of F1 and F2 using SOH-CAH-TOA. Right. So, and that's it for our lesson today, guys. Please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And then if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.